Hey there, Marcus Hutzel here, and in this video I'm going to show you and mainly let you hear what bad or improper gain structure is doing to your audio. And you can actually hear my bad gain structure right now. I'll address it in a sec, but as you can see here in my setup, I've got a small audio system as if I were in a live audio environment. I'm amplifying my voice in this space with a wireless microphone, a mixing console, and two speakers back there, while also recording this same signal because it's live audio and live audio personnel where I see a lot of gain structure issues. It's where I hear the results of that bad gain structure and where I find it's the hardest to correct these bad habits and remind audio personnel of how our equipment was designed to work, why it was designed to work that way, and how we need to work our way through the system to ensure our equipment does what we want it to do and that our audio has as little noise as possible. So you should be able to hear the result of this bad gain structure that I've set up because there's a lot of noise in the audio in this video. There's this decently loud hiss. And this is the result of poor gain structure. And this is the raw audio completely unprocessed as it passes through this system. And the reason this audio has so much noise is that I've gain structured this system improperly or backwards. And this is unfortunately how I see a lot of live PA systems set up, but that ultimately cause the audio personnel more problems that they can't get themselves out of. But if I just regain structure, I can clean up this noise very quickly. And now I've gotten rid of that hiss. I've gotten rid of that noise. And I'm still amplifying the signal out of those speakers at the same SPL or volume level to my ears here in my test room. But this is not audio editing. I didn't do anything to this audio in post. This audio is completely unaltered as it travels from this mic through this equipment to that set of speakers behind me and also to the recording that you're listening to that I'm recording here on this Blackmagic Video Assist. I'm using the exact same microphone, the same wireless mic transmitter and receiver, the same audio console. I've just gain structured my mic and my audio console properly by starting at the beginning and pushing my signal through the system. So for those of you out there in the live audio production world, listen up because that noisy audio you heard at the beginning of this video is a problem that I see and hear every day. And yes, this noise is also getting to and coming out of your PA system. You may not hear this noise as much coming out of a speaker since the speakers may be further away or the ambient noise of people in the room may just mask the system noise, but it is present. And it will certainly become a problem when you record that live event and when you live stream that live event. And I'm going to tell you why it's happening and how to fix it. And it all comes back to Audio Basics, Audio 101. So let me recap these specific Audio 101 topics. Number one, audio in the air becomes electricity as soon as it hits the diaphragm of a microphone. So when we're talking about audio equipment, we have to remember it's all about electricity as our signal flows into this mic, down an XLR cable to a console, or from a wireless mic transmitter to its receiver, then to a console and to the digital audio file that gets recorded and every point in between. And yes, out to the amplifiers and speakers as well. Audio is literally electricity when it's inside our equipment, and we have to treat it as electricity. And number two, electricity and electrical equipment is noisy, and we don't want that noise in our audio. But as long as we treat our audio as electricity and use our equipment to gain up our primary audio signals, such as my voice, up and over the inherent noise in our electronics, then we give our equipment and our audio signal the best possible chance of not adding or amplifying all that system noise to the final signal. But the only way to do that is by starting at the beginning of your signal chain, by using our gain stage points in order, starting at the sound source and then moving to the next device in line, then the next, pushing our electrical audio signals through the system and never working in reverse. That's why our equipment has meters, so we can see those electrical audio signals. So whether you're just recording or whether you're amplifying audio for a live event with speakers, there's no difference in the way the equipment works. There's no difference in how a preamp works or how much noise our equipment can induce on your signal. So we shouldn't necessarily treat the equipment differently just because we may be in a different environment. So how is this audio so noisy, but this audio is so clean? It's because much of the time in live audio setups, many live audio engineers gain structure backwards. What do I mean? Well, take this small PA system where I have a couple of speakers out in a room. Often I'll see that the engineer or the A1 turns on the speakers or amps first and sets them to some arbitrary and usually too high of a level without first running signal to them. Then they back up to the console and they put their faders at 0. Then they attempt to set input gains from that point using their ears to get enough volume out of their speakers. And yes, this does get audio out of the speakers, but it's not good audio and it's not the way to set gain. And let me go back to this noisy audio real quick, because the result of this backwards method is that engineers are not only ignoring their audio meters and ignoring the actual electrical levels in their equipment, but this most often results in really low input gain on each individual microphone channel. And if we look at my microphone channel here, I'm on channel 1, we can see, even though I can hear this out of my PA decently well for this space, I've got very low input gain on this channel. The result of that is I'm sending a very low signal out of the console, and so over here at my record deck, I've had to turn up the inputs on that all the way up, and therefore I'm using the preamps inside the video assist, which is then amplifying and having to boost that signal itself because I'm sending such a low level out, and we're getting all of this noise. And one of the reasons that this often results in this low input gain on the console is because if we do have our speakers turned on and all the way up or really high, and our faders are at 0, one way to limit the volume coming out of those speakers would be with a preamp, because the preamp would be the only other thing stopping our signal from our microphone getting out to the speaker, because we've left an open path from the microphone to that speaker. But that's not what preamps are for. Mic preamps are not there for volume control out of your speakers. Mic preamps are there to gain our low-level mic signals, which generate a very small amount of electrical voltage, up to a stronger line-level voltage for the console, because the console was designed to work most efficiently, that is, with as little noise as possible, when the audio traveling through its circuits is at line level. If we gain low at the beginning and run low electrical levels through our console, then our desired signal, my voice, sits down near the noise floor of either the wireless receiver and or the console, and then when we send that signal out again to something else like this video assist, that next device, be it a recorder or be it a speaker, will have to gain up that low-level signal. But again, that low-level signal is now embedded with the noise that we picked up along the way. So when we do use that next device to amplify this signal, we end up with more noise at our end destinations. The only way to give the rest of the console line level audio voltage from our low voltage mic signals and stay away from our noise floor is to watch our audio input meters and gain our inputs up to line level first before ever sending them out of a console and on to the next device. Hang on, I'm going to go back to better sounding audio. There, that's better. So the same applies to wireless microphones as well. The difference is that with wireless mics, be it a handheld or a pack with a lavalier like I'm wearing, the difference is that with these units, the first preamp is actually in the pack or the transmitter itself, which these days can often be controlled from the receiver like this Shure ULXD unit. So when using wireless mics, we have to use the meters and gain stage on the receiver before we ever get to a console. When you're in a live audio environment, the final volume out of your speakers needs to be controlled by either amplifier input attenuators, output faders on the console, and channel faders on the console. Never sacrifice proper strong input gain for output volume at your speakers. And remember this very important fact about faders specifically, and that is, if a fader is set at 0, it's just not cutting or boosting the signal going through that point. If I only gain up my input to, let's say, negative 40 dBFS on this console, then only negative 40 dBFS gets sent to the fader. And if my fader is at 0, then only that same negative 40 dBFS gets sent to the main fader, and only negative 40 dBFS gets sent out of the console. Putting a fader at 0 doesn't automatically mean a strong level is coming out of the console. It doesn't automatically boost anything to line level. The equipment does what you tell it to do. Faders can boost the signal a bit if you're above that 0 mark, but usually by only about 10 dB more. But they can only control what you send them from upstream of that particular point. Faders and console outputs don't normalize anything or automatically set your outputs to any level. They do what you tell them to do. If they're at 0, they simply pass a signal that you're sending to them. And this is why you have to gain and set levels visually with your audio meters. All right, so I'm going to regain structure this system from scratch 2 ways, and we'll listen to the results of those gain structured systems as that audio gets recorded over to this Blackmagic Video Assist, and again, structuring for volume levels coming out of those speakers. In the first method, I'll gain structure backwards from the speaker, and I'll limit the volume of the speakers with preamps. And in the second method, I'll work forward through the system. All right, here we go. All right, so you'll have to hear me on my second lavalier mic that I'm using to record, because I've got to turn the speakers down and turn down the level to the Video Assist. So I'm going to basically just set everything back to nothing. I'm going to go and I'm going to turn down the receiver to 0 dB, which means the receiver is not adding gain or cutting gain from this wireless pack and this WL185, Shure WL185 that I'm wearing. So we've set that. And because I want to do this the improper way first, I'm going to go over to my QSC K8s. I'm going to put them at 75% of maximum, because that is a common thing that I see people do. They'll just set them at 75% and then they'll come back to their console. Some people will just leave their wireless mic systems at 0, and then they'll come over to the console, put our main fader at 0 or unity, not boosting or cutting anything we're sending to it. And I'll put my channel fader at 0. And actually, wow, I can already hear that coming out of the speakers. It's plenty loud for this space. So some engineers will go, all right, well, I'm good to go. They'll just maybe gain it up a little bit if it's not quite loud enough. But a couple things wrong with that. Number one, look at my input meter here. My input is way down here, buried in the noise floor of this console. And you're actually still hearing me on the Rode Lav. So to let you hear the audio that's getting recorded through this system over to the Blackmagic Video Assist, we have to go here and set our audio level here. If this is how the front of house engineer, the A1, is gain structuring their system, they're like, cool, my job's done. I've got audio out of my system. I'm good to go. I can hear the speakers hissing a little bit, but who cares? It's in the room. But the recording operator, or anywhere we send this signal, is getting a noisy signal. Some of that noise I'm hearing from the speakers is from the console, some of it's from the speaker itself. But if I'm going to send this over to a record deck, we can see here on the record deck that my input level is very low. Okay, great, well, let's just boost this up on the record deck until we have enough level visually. Check, 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 1, 2. I'm gonna have to go up to check, 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 1, 2. Hey, 2, let's go up to 40, 47 on both, if we can get there. There we go, and now you can hear the noisy audio that we get from having gain structured from the speaker backwards, limiting our input at the console and limiting our input at the wireless mic receiver. So the equipment's doing exactly what we've told it. We've gained low, we've kept our main audio signal near the noise floor of the receiver, we've kept our main audio signal near the noise floor of the console. It gets sent out at a low level. The speakers are turned way up, so they can take this low level and amplify it, no problem. But recording devices receive the same level. They have to use their own internal gain input gains to gain up, and they are also now amplifying all of this noise. And this is one of the fundamental problems that I see from live audio engineers, is that they're gain structuring for volume of their speakers, while again completely ignoring the electrical levels and resulting in this noisy audio. And one might think, okay, well, yes, we had to gain our external record decks up, but that's the record deck's fault. Not really, because now you're actually hearing the internal recording from the console itself. I've had to go in this video edit and boost the level, because if we look at the level here on the left-right bus, let's solo this guy here. Check 1, 2, hey, 2, 2. I have to hit this microphone very hard to send enough signal for it to even register on the meters. Hey, 2. So this is the level being recorded on the console. So just because it lives in the console in this specific recording that you're hearing doesn't mean it's clean. It's still buried in the noise floor of this console. So let's do this a little bit better. Let's turn off everything real quick. You're hearing me on the Rode Lav again. Gonna start by turning my speakers down all the way. Now we'll come over here and we'll gain structure with our eyes. So I've got the same microphone on, but you can see here I've got an input meter on the receiver, but I can't see any levels. I can barely see one LED there as I speak. So I'm just going to keep gaining this up check, 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 1, 2, until I hit a level check, 1, 2, 2, 2, 2, where if I do get loud, it won't clip out here either. Hey, 2, 2, 2, let's leave it there. Let's leave it at plus 13. Why plus 13? Because that's the level that I need to gain the signal up to electrically for this receiver to have what it needs. All right, so at the console, I'll leave my faders down for a minute. I'm going to gain structure my input visually here. Check 1, 2. We can already see without touching the preamp from before, I've got much stronger level in here. So I'm going to go ahead and gain this up. Check 1, 2, 2 with my eyes. Check 1, 2. Hitting, 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 hitting. Check 1, 2. Hitting about negative 18 on average here, negative 18 dBFS. Check 1, 2, 2, 2, 2. I'll go ahead and give it just a touch more. Hey, 2. Even if I get loud, I'm not clipping out the preamp, so that's a good level. Now I'm going to leave the main fader down. I'm going to push my channel fader up to unity. I'll push my main fader up to unity. Check 1, 2. Now we can see here on both the input and the master output, I've got nice, strong, healthy levels. We'll go ahead and set those. We'll walk over to our speakers and turn them up. Now, granted, I have to be a little bit careful since I'm wearing the mic and I'm in front of the speakers. It's where it's good to have someone else talking and someone else turning up the speakers. And this little bit of legwork is sometimes necessary to set your overall gain for the room. So check, check, 1, 2, 2, 2, 2, 2, 2, 1, 2, 1, 2, hey, hey, 2, 2, check 2, check 2, check 2, 1, 2, 1, 2, 1, 2, 1, 2, check, check, 1, 2, 2, 2, check, check, 1, 2. All right, so that's a good level for this room, for this space. And now I've got the best of both worlds. I've got healthy input gains on my meters here on the wireless receiver. I've got healthy input gains hitting, that negative 18 dBFS, which equates to line level here on the Behringer X32 console. I'm sending out at unity so my faders aren't cutting or boosting, and then we set the speakers to a good volume for the room. Now, yes, you should always leave headroom. Headroom being enough so that if your talent gets louder, they don't clip out the receiver, they don't clip out the preamp, and headroom to be able to turn up those speakers from the console. But leaving headroom is part of gain structure. You're structuring the entire system, not just individual or disjointed components. You have to think about all the components in the system when you're gain structuring. But I almost forgot, if you look here on the video assist, we're clipping the heck out of this and you're still hearing me on whatever microphone I put on screen, because if I let you hear this, it's gonna be really distorted. So we will turn this down to where we're getting a good level. Check 1, 2. Hey, hey, 2, 2, 2, 2, 2, 2, 2, 1, 2. So now I'm able to turn the inputs down here on the video assist. And now we have much cleaner audio because we gain structured from the microphone to the pack to the receiver to the console, then to the speakers. That ensures we get nice healthy levels out of the console and out to everywhere else. And I'll switch over to the recording that I'm getting on the console now. And now you can hear this sounds a lot better. I haven't had to take this recording on the console and amplify it as much for the video edit. And hang on, I'll let you hear the before and after. Here's a recording off of the left-right mix bus of the Behringer X32 console when I've gain structured poorly. Check, check, 1, 2. I've had to boost this in post so that you can actually hear my voice, but you can also hear the system noise that came with it when I had to boost in post. Here's with poor gain structure. And now here's the recording from the console having regained structure upstream at the wireless mic, then the preamp, and here is the resultant cleaner audio that we get. And we have had to boost this a little bit in post too, but not near as much. So because we haven't had to boost as much in post, we don't get the same amount of noise boost as we would when we had bad gain structure. So that's it. I can't emphasize enough how much you need to start at the sound source, gain up at every point along the way, pushing your signal through the system. If you start at the end and try to pull, the pulling is actually the device's own input gain or input attenuator trying to pull that signal. And if that signal is too low, it's got to pull harder. It's going to pull the noise with it. I don't know, I think that's a good analogy. You never want to pull your audio through the system. You want to push it. You push it from the sound source into the mic, pick the right mic for that application. You gain up either the pack itself or use the gain on the receiver. Depends on the unit you're using as to whether you can control it here or here. Luckily on these ULXD units, we can control the gain right here on the receiver. Make sure you're gaining up to where you see a good strong audio level here on the meters. Leave yourself some headroom, of course. Gain up visually on the input meters here on the console. Look at that, nice, healthy meters. Then you can push your faders up, then you can turn your speakers up. That's going to ensure not only that you get clean audio through the system, but you can amplify a dirty signal or noisy signal the same way you can amplify a clean signal. You're just going to have cleaner audio for the entirety of your audio system. And that is the goal because we're working with electronic equipment. So I hope this has been helpful, and go out there, start at the beginning, work your way forward through the system, never in reverse, and I'll see you out there. Later.